Let it snow, let it snow, let it snow.
It's December, and I want it to snow. If not outside, then on my computer screen in a window kind of like this. So every day I've been working on my program here, and tomorrow is the 24th, and this is what I got. There is work to be done. Today I'm going to see if I can find a way to avoid these spikes. The last time I worked with the spikes, I did it like this. I was looking at the array of landed snowflakes, and if one X position was too much taller than the next, then it moved a snowflake. And the code for that was way down here in Animate. I'm avoiding the spikes. I'm looking at the height of this one and the height of its next neighbor, and then just see, okay, if this one is more than 2 taller than the next, then it removes a snowflake from this and adds one to the next. And then it does the same for the neighbor to the left, the previous neighbor. So the same principle should be possible, but I can't just look at the X positions because I have all these platforms, and if I look at some of them, like here and I have some here. I think this is around here. I have one at 115, one at 208, and one at 457. 457 is max Y. And then the next one, it's clear that this one would be a neighbor to this one, and this one would be a neighbor to this one, and this one would be a neighbor to this one. There's no problem. That would still be the same. But then for the next one, I suddenly have this. It's not the same, but it's close, so they would be neighbors. But how do I make the code so that these two are still neighbors, even though they're not exactly the same? And then it goes all here. Now, this one does not have a neighbor. There's nothing here. So I need to analyze these platforms and find all the neighbors. And for that, I'm going to make another drawing. So figuring out if two platforms are neighbors. It could be easy if, say, one was here. This is a platform, this is a single X value here, and then the next one is right next to it here with the same base value. So if base for one platform is equal to, let's just use all three equals, the base of the next one, they are neighbors. But also, if one has a base and the other one is close by, it's just a few pixels above it. So if base is almost equal to, I'm just writing it like that. It doesn't work in JavaScript, but it works in math. So if base is approximately the same, close, then they're neighbors. But if they're too far apart, like this, then there would be no, then they're not neighbors. Base is not equal to base at all, or it's not even close to be. I'm going to write it like this. So base is not approximately like the other base. So they're not neighbors. And then, okay, but that would be if I just have two. But now I have, sometimes I have 3 and sometimes I have 2. But I always have 1. I'm looking through my platforms one at a time. One platform, and then that could have 1, 2, 3 possible neighbors. Which one is the actual neighbor? Right now it's easy, it's that one. But for the computer to say, okay, let's look at the base and the difference on the distance. I'm calling this the dist to that one, and to that one. This one here has the lowest, the smallest distance from this one. So that would be our neighbor. Let's go and try and write the code for this. And where would I put it? Well, I need the platforms, and they are created here. So right after having created all the platforms, I would find neighboring platforms. And I would do that by looping through all the existing platforms. And then for each X position, I would need to find the platforms, because that would be this one. There could be more than one for each position. I have to go through all of them. So let the platforms be all platforms at position X and loop through them. And then my platform that I'm going to examine is this. Platforms I, the ith platform. The possible neighbors, that would then be all platforms of not X but X plus 1. That would be the next. And then I would need to loop through all of them, like here. So for let, I'm running out of variables here. Oops. I'm using J now. My possible neighbor, I'm just calling it neighbor, is my possible neighbors at position J. Then I need to find the distance. Let my dist be this position, this platform space, minus the neighbors base. And here's the problem, that now for this one, this space would be a greater number than this one, but it would be a smaller number than this one. So this would sometimes be positive, sometimes negative. I have to avoid that. So I'm just using this math.abs that removes the sign from it. So now I have my distance. I just need to figure out if this is the smallest possible distance. And I can do that if I start by I need to remember the distance outside this loop. So let smallest distance be, what should it be? It should be a large number. I'm going to use this maximum integer. I think there's something mdn max integer. The largest number, max safe integer. Yeah, that's the largest number there is. So no distance can be greater. I know it's insanely large, but let's just try that. And then say, okay, if this dist is smaller than the smallest distance, that means this one would now be the smallest. And this neighbor is actually the possible neighbor. So that would also say, okay, possible neighbor, not just neighbor, 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 possible neighbor. Boom, boom, boom. Closest neighbor. First it's null, and then the closest neighbor would be this neighbor. And that should go through all of them. And we have the closest neighbor, which is the neighbor. So let's just say that this platform has a neighbor. I'm calling it next because it's the next neighbor. And that would be the closest neighbor. Let's just go and take a look at how this turns out. Cannot read property length. Here. Of course, possible neighbors might not exist, for the last one has no neighbors. So I need to put this in an if statement. If possible neighbors, if it exists at all, then all of this. Let's just indent it a bit. Cool. Looks like it works. And let's take a look here at my problem areas. Where were they? 45. The 208 has a next. Can I see what is the next? That is this, probably this one with 208, and then there's one here at 206, and that means the next should be, yeah, the next is this one. And then this one should have no next. It has a next of 115, but this one has the same next. And see, yeah, now there's a problem. One platform is neighbor to two other platforms, both one right next to it and then one that is way lower. So, how do I fix that? Well, I already talked about it, actually. Here, if the bases were too far apart, they wouldn't be neighbors. So, these two here, where did it go? So, this one at 206 could not be neighbor to 115. There's simply too far between them. So I'm going to here and say, okay, but the distance. If the smallest distance is less than, and I'm just going to pick a number of that's in there, 10 pixels, then and only then can we have a neighbor. Also, I find it quite difficult to figure out this next, which one is it, because the heights change all the time. So I'm going to, here when I push something in, I'm also pushing an x value, x colon x, and here x colon x. That would be this x. So now they have different x values, all of them. I don't use it just to recognize them. So let's see. What do we have here? Look at the same ones. What's position 45? See, now I had x45, so I know where they are. And the 208 has a next. This one 46. 46 at 206. And it does not have a next. See? It's neighborless. Because it would be, which one is it? Is it 206? It's here. It's right next to the stem of the letter. So it has no neighbors on that side. Of course it has a neighbor to the left of it. And that's actually pretty easy to find. Because when the next neighbor, when this one has its next neighbor, then the next neighbor would have as a previous neighbor this one. So I could say, okay, then the closest neighbors previous would be this platform. And that would link them back and forth. Let's just try and see if my idea works. Looking back at these, 46. 206 has no next, but it has a previous. That would be 45. This one here, 45, and that has a next and a previous. And the next is 46 and the previous here. So perfectly. Now they're all linked together. Now I just need to fix the code here that avoids the spikes. So I'm not going to fix this code. I'm just going to rewrite it completely, but keeping a look upon it. So I'm looping for through all the x's in the all my platforms. And for each x value, I would find a list of platforms for this position. And that would be my all platforms x. And then I'm going to loop through them. I usually use I for that. And then I have my platform. This platform I'm looking at would be my platforms at position I. And then I just need to check my neighbor. So my neighbor, my next neighbor, that would be my platform dot next. And then say, like here, I say if this height -2 is greater than the next height. And that was before when I only looked at the heights, but now I also need to look at the base. So if my platform's base, say if that minus my platform's height, because a higher amount of snow like this goes closer to 0, so it gets minus. So if that is smaller than my next dot base minus my next dot height, then I would need to move a snowflake. But that is only if it is one snowflake more, if there's one more here. But say I want there to be at least 2. So now I need to say, okay, add 2. So if that means if I go up, 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 and then 2 down, and if it's still closer to the top than the next one, then I move a snowflake over. So let's see here. Move a snowflake from platform to next. And that means first I clear one, like here. And my x value is still my x value. And my y value is no longer this, but my platform base minus my platform height. And now I don't care about the +2 here. And I move a single pixel. This should be okay. And then I can subtract 1 from the platform height. Cool. And now I just need to draw one for the next here. Draw a snowflake, and this is no longer what I want. I want the next dot base minus the next dot height. And I also need to increment the next height. This should move a snowflake to the right. Let's try and see how it works. There's an error in line 267, base of undefined. Ah, yes, of course, at some point there might not actually be a next neighbor. So I just have to say, okay, if next exists and all of this, then try. See. It's working. And now it moves to one side. I also want to move them to the left, so I don't get the sawtooth pattern here. So that would mean I also need a prev. Let prev be my platform's prev neighbor. And then if, and I just as well check if prev exists, and my platform base minus my platform height, if that +1, and I'm not plussing 2 to the left, it's 1 less. If that is less than the prev dot base minus the prev dot height, then I'm going to move a snowflake from platform to prev. And that means this one would be exactly the same. I'm removing one from the platform. And this one would then be, everything would be different. X is not +1 anymore, it's now -1. And it's prev, and it's prev, and it's prev. So I'm just going to uncomment all this old stuff just to be sure it doesn't run. I don't think it does, but oh, something weird is going on. It looks like it's cutting into the letters themselves. Why is that? I shouldn't move unless of course there has to be at least 2 snowflakes. Otherwise I'm moving the platform itself. So only move if platform height is greater than 2. Then we can start moving snowflakes. And only then. So how does this look? I'm just going to speed it up a bit. This looks perfect. The snow is landing and it's laying on the slopes, and it even does like this, fills out the gaps. This is wonderful. I'm going to commit. I'm calling snow landing perfect on platforms. So now I'm actually done before the 24th. This looks perfect. I could use a bit of cleanup in my code and maybe also fix the responsiveness just a tiny bit. That is all something for tomorrow. See you then.
Let it snow.